Today we're going to be talking about proportionality theorems, and our objective is that we will be able to use proportionality theorems with triangles and parallel lines to calculate segment lengths. So in the diagram, AB is parallel to CD, BD equals 15, AC equals 10, and CE equals 18. Find DE, which I'm going to mark with an X. If a line is parallel to the side of a triangle, then it divides the side it intersects proportionally. So that means that BD over AC would equal DE over CE. So the piece on the top over the piece at the bottom, piece at the top over the piece at the bottom. So 15 over 10 would have to equal X over 18. And remember, we solve proportions by cross multiplying. So we'll have 15 times 18 equals 10 times X. 15 times 18 is 270 equals 10X. Divide both sides by 10. And that gives us X equals 27, or DE equals 27. We can also use the reverse to help us solve. If the pieces of the sides are proportional, then the line through the triangle is parallel to the side. So we want to determine if PQ is parallel to LM. Well, if it is, then LP over MQ would have to equal PN over QN. LP is 18 over MQ, which is 27, and that simplifies to 2 over 3. For PN over QN, we have 16 over 24, which also simplifies to 2 over 3. So yes, PQ is parallel to LM because these simplified to the same number. What if we have 3 lines? So BC is parallel to DE, which is parallel to FG. So all 3 of these are parallel. If 3 parallel lines intersect 2 transversals, which would be this line here and this line here, then the parallel divides the transversal proportionally. So if we have BD, and I'm going to use my highlighter to help with this, BD over DF is equal to something over EG. Well, we went middle piece to end piece. So in our proportion, we must also have to go from middle piece to end piece. Or sorry, middle piece to end piece. So CE is our missing segment. If we have AB and AF, AB, and then AF is the long side of the whole thing, and then we have BC, which is a bottom, it's the bottom of this smaller triangle. AF was the side of this big triangle, so we're going to need the bottom of the big triangle, which is FG. I now want you to pause your video and try and fill in these 4 proportions there. now that you've given it a try, check your answers. Our final rule for today: if a line bisects an angle of a triangle, it will divide the intersecting side proportionally. So let's find the missing side length x. So what this is saying is this line bisects angle C into these two smaller pieces. Therefore, AD over DB must equal CA over CB. AD is 3, DB is x, CA is 9, and CB is 12. Again, we're going to cross multiply and we get 9x equals 3 times 12. So 9x equals 36. And if we divide both sides, we get that x equals 4. The same rule helps with this problem. The one thing is, we know this whole length is 8. We don't know what the length here is where our bisector cuts into this side. Since we know the whole thing's 8 and this piece is x, this missing piece must be 8 minus x. Now we can set up our proportion. X over 8 minus x will equal 9 over 3. We're going to cross multiply, so we'll have 3 times 8 minus x equals 9x. Distribute. Then we need to get all the x's on one side, so I'm going to add 3x to the other side. And then divide both sides by 12. And we get that x is equal to 2. That's all for today. I'll see you in class.